Okay, we left off 3233 part 1. This is 3233 part 2. There's a difference between average rate of change and instantaneous rate of change. It's very important in calculus. Average rate of change is simply the slope. We don't really call it average rate of change a lot, which we should, because it would help in calculus. For example, here is the total amount appropriated annually in billions of dollars for the U.S. Department of Ed in recent years. Find the average rate of change per year in Department of Education appropriation from 2009 to 2013. The average rate of change per year. Okay, so we kind of want to look at this almost like order pairs. Okay, we have the point, we have the point 2009 is the X or the T. 2009, it was 63.52 billion. Let's put 63.52, we know that's billion. And in 2013, it was 65.7 billion. So if I want to find the average rate of change, we'll subtract the y coordinates, 65.7 minus 63.52, and divide by the x's subtracted from each other, 2013 minus 2009. Now, you might have found this intuitively. You might have just been like, well, I'll just subtract, the billions and then divide by the 4 years, okay, which that would be the average per year. But I just want you to see, if you set it up this way, we're really just talking about the slope. So if we subtract 65.7 minus 63.52, we get 2.18, and that's over 4 years. So then I would take 2.18, divide it by 4, and I get 0.545. Okay, so about $500 million, $0.545 billion per year is the average. 0.545, about $500 million per year. That's the average rate of change. And really, mathematically what we're doing is finding the slope of the line, right, from 2009 to 2013. If I would be able to draw a straight line through there, I just found the slope of it, okay? That's what average rate of change is. Now, instantaneous rate of change is something different. Instantaneous rate of change is right at a certain instant. How is the y value changing with respect to the x value? The instantaneous rate of change for a function when x is a is the limit as h approaches 0 of f of a plus h minus f of a. Okay, that's why we were practicing that in the previous chapter, being able to find this value, okay? It's the limit. H is getting really tiny, okay? So we're basically finding the y coordinate subtraction of 2 points that are really, really close together because H is almost 0. H is approaching 0. So we're just a little bigger than A, okay? And that's what we're doing. We're finding that rate of change, instantaneous rate of change, not average over time. Okay, so let's say the distance in feet of an object from a starting point is given by this function. Okay, we want to know the average velocity from 2 seconds to 4 seconds. As soon as you see the word average, you're thinking slope. Okay, so average rate of change, or the average velocity, okay, since this is in distance times seconds, they sometimes use velocity instead of saying rate of change. Okay, this is the average rate of change of the object from 2 seconds to 4 seconds. Okay? So in other words, we're putting our time is 2 to 4. S of 2, okay, when I put 2 in, I get 38. If I take 2 squared times 2 minus 5 times 2 plus 30, okay, or plus 40, I'm sorry. That's 38. And if I put 4 in for t up here, 2 times 4 squared minus 5 times 4 plus 40, I end up getting 52. So if I want the average velocity or the average rate of change, I take 52 minus 38 divided by 4 minus 2, and I get 7. So that's 7 feet per second. Okay, instantaneous velocity at 4. Notice it doesn't say from 4 to 4. It just says at 4. Then I have to do my limit. The limit as h approaches 0 of s of 4 plus h minus s of 4 all over h. Okay, it's just this formula, except they told me that a was 4. Okay, so instead of f of a plus h, we have 4 plus h. Okay, so s of 4 plus h. I'm going to put 4 plus h in for t, right? So I'm going to have the limit as h approaches 0 of 2 times, instead of t squared, it's 4 plus h squared. Instead of t, it's 4 plus h plus 40. Okay, it's neater on the next page. Let me just show you. Okay, so we take s of 4 plus h, is what I said on the other page. 4 plus h squared minus 5 times 4 plus h plus 40. If I square this, 4 plus h times 4 plus h, okay, is what they're doing there. 4 plus h times 4 plus h. We have to FOIL it. So I get 16 plus 4h plus 4h, that's plus 8h plus h squared. I'm going to take my 5 through, and I get minus 20 minus 5h plus 40. I take my 2 through, 2 times 16 is 32, 2 times 8h is 16h, 2 times h squared is 2h squared. Combine like terms, we get 2h squared. We get 16h's minus 5h's, that's 11h. We have 32 minus 20 is 12, plus 40 is 52. So that's s of 4 plus h. And then we're going to subtract s of 4. Okay, remember the formula was s of 4 plus h, which we just found, minus s of 4. So in other words, stick 4 in here. We already did. We got 52. Okay, so we take s of 4 plus h minus s of 4 all over h. So what happens then?
Excuse me for the...
And then the 52 minus 52, of course, would go away. So we have 2h squared plus 11h all over h. H factors, we can cancel the h there. And we just have 2h plus 11. Now let's put 0 in for h. 2 times 0 is 0. 0 plus 11 is 11. So it's the average rate of change was 7 feet per second, but that instantaneous rate of change right at 4 is 11 feet per second. Okay, right at the time when t is 4. So average rate of change and instantaneous rate of change are completely different. Here's something for business majors. A company determines that the cost in dollars to manufacture X cases of the DVD Mathematicians Caught in Embarrassing Moments is given by this, as long as X is between 0 and 7. Here's your cost. Find the average change per case from 1 to 5. Okay, so that's slope as soon as you see average. So I'm going to put 1 in. We get 100 plus 15, 115 minus 1 is 114. I'm going to put 5 in and see what I get. And then I'm going to find the slope. Okay? When I put 5 in, I got 150. When I put 1 in, I got 114. So 150 minus 114 over 5 minus 1, which is 4. You get 9 for the average rate of change. $9 for each case when production increased from 1 to 5. The average cost, okay? The total cost on average increased by $9 per case. Okay? That's what they mean by average. If they want find the additional cost when production is increased from 1 to 2. Well, from 1 to 2, when I put 2 into that cost function, I got 126. When I put 1 in, I got 114. So 12. The additional cost to produce the second case is $12. Here we go with instantaneous rate of change. Find the instantaneous rate of change of cost with respect to the number of cases produced when just one case is produced. So now X is 1. So I'm going to take the limit as H approaches 0 of the cost function. Since X is 1, we're doing 1 plus H minus C of 1 over H. So I put 1 plus H in everywhere. You know, the cost function was back here, 100 plus 15X minus X squared. Okay, so C of X was 100 minus 15X minus X squared. So just so you see, we're putting 1 plus H everywhere there's an X. So it's 100 plus 15 times 1 plus H minus, okay, because we put 1 plus H there, 1 plus H squared. And then we're going to subtract what we get when we put 1 in for X, which was 100 plus 15 minus 1, which was 114. Okay. So there's the 114. So we have 100 plus 15 plus 15H minus 1 minus 2H minus H squared, because be careful, this is 1 plus H times 1 plus H. Okay, to figure that out, you have to do some foiling. And then this whole thing was 114. A lot of algebra involved here. You end up, when we put H, we put 0 in for H, I think you get 13. Okay. So we just combine the like terms, etc., factor the H out. I don't usually show this step. I kind of see that I'm taking H out of each term. That gives me 13 there and an H. Then I finally can put 0 in for H. 13 minus 0 is 13. Okay? So in other words, what this is saying is when one case is manufactured, the cost of increasing at the rate of $13 per case. When one case is manufactured, the cost is increasing at a rate of $13 per case. Notice that's kind of close to the value calculated in part B. From 1 to 2, we said 12. So we got close. It's actually, you know, the instantaneous rate of change right at 1 is 13. From 1 to 2 was 12. Okay. So for the cost function in the previous example, find the instantaneous rate of change of cost when 5 cases are made. Same equation, same exact equation, okay? But instead of doing 1 plus H, we're doing 5 plus H. Instead of doing C of 1, we're doing C of 5. Okay, so we do that exact, all the same calculations. You should end up getting 5. You can pause me if you need to see that. It's the same calculations. When 5 cases are manufactured, the cost is increasing at the rate of $5 per case. That is, the marginal cost when X is 5 is only $5. Note that the number of items produced goes up. As the number of items goes up,